This is a replica of a flyball governor patented by Woodward Governor in 1870. We have an input shaft, which is connected to an output shaft via a belt drive. The output shaft is geared through bevel gears to this flyball mechanism. These flyballs fly out with centrifugal force as the speed of the shaft increases. On the output shaft we have a clutch with two separate drums. As the flyballs fly out, the linkage moves the friction clutch in and out along the output shaft. So usually the input shaft is attached to a water wheel or a steam turbine, and the output shaft is attached to a gate or a valve which controls the speed of the shaft. So at slow speeds, the flyballs do not extend very far, and the output shaft is turning in the same direction as the input shaft. But as the speed increases, the balls are extended fairly far out, and the output shaft is turning in the opposite direction, which would tend to close the valve and slow down the speed. At the set point speed, the flyballs are at the perfect height such that the output shaft doesn't move at all. At slow speeds, the far drum of the disc is being contacted by the friction clutch, and the output shaft is turning clockwise. At high speeds, the flyball mechanism moves the friction clutch so it contacts the inner drum, which turns the output shaft in the counterclockwise direction. At the set point speed, the friction clutch is centered between the discs, and the output shaft is stationary. At all other speeds, the friction clutch turns the output shaft in the desired direction to slow or speed the output. Here you can see how the flyball mechanism operates. As the flyballs extend out with centrifugal force, this link pivots and moves the friction clutch from one drum to the other. So this linkage is coupled to an inner shaft, which is connected directly to the friction clutch. Here you can also see the bevel drive that couples the shaft rotation to the flyball mechanism. So again, at slow speeds, the friction clutch is connected to the outer drum, causing the output shaft to turn clockwise. And at high speeds, the friction clutch is attached to the inner drum, causing the output shaft to turn counterclockwise.